So in this section, we're going to discuss exponent properties involving quotients, which includes dividing expressions with the same base raised to a power and then raising a quotient to a power. So the first thing we're going to do is write out the following quotient as a product. So what that means is a to the fifth, I know, means a times a times a times a times a. So a times itself 5 times. And a cubed means a times a on the bottom. And I could add, if I wanted to, the middle dots if needed. Now, every time you have an a on the top and an a on the bottom, they cancel. So that could cancel, that could cancel, and that could cancel, which leaves you with a squared. So the rule that we can come up with for dividing expressions that have the same base, in this case the base was both a and they're being divided, you can see that the exponent was 5 and 3 and it ended up being 2, so you can subtract the exponents. And so the rule that we're going to write is that if we have a to the m over a to the n, we can make that a to the m minus n. Now, something I just want to point out, although it won't come up until the next section, 8.3, is that when you have a to the m minus n, if you think of this as a fraction, well, it's not a fraction right now because obviously we don't have a fraction bar or denominator, but it would be that over 1. So you won't need to recognize this until the next section, but just know that when you apply this subtraction rule, you assume that it's the numerator if it were a fraction. So now we're going to use the rule that we just came up with to simplify the following expressions, and we're going to be allowed to write our answer using an exponent. So 4 to the 7th over 4 to the 2nd would become 4 to the 5th. Try the next examples, pause the video, press play when you're ready to check your answer. So we have 8 to the 10th over 8 to the 4th would be 8 to the 6th. On the numerator, we'd have 5 to the 4th times 5 to the 8th would be 5 to the 12th, but then 5 to the 12th over 5 to the 7th would become 5 to the 5th. Here our base is negative 3. 9 minus 3 would make it negative 3 to the 6th, but since there's going to be an even number of negative signs, that's going to be a positive answer in the end. For these two type of problems, we can make the second expression a fraction by putting it over 1. You can multiply across and then apply your subtraction rule because of division, so the final answer would be x squared. Then we have 9 to the 7th, negative 2 to the 1st just means it's negative 2, 6 to the 5th, and r to the 3rd. So now we're going to write out the following quotient as a product, and we are raising it to the 4th power. So remember that when you're raising anything to the 4th power, it means to multiply it by itself 4 times. And so in this case, the thing that's getting multiplied by itself is a over b times a over b times a over b times a over b. So to multiply fractions, you multiply straight across. So on the top I have a times a times a times a, which is a to the 4th, over b times b times b times b, which would be b to the 4th. So if you're raising a quotient to a power, you can actually just give each piece the power. So back on the first slide where we have these rules, the rules that we'd come up with is a over b raised to the m power would become a to the m over b to the m. And this is very similar to when we had radical a over b and we made it into radical a over radical b. The idea that if they're both inside the radical, you can give them each their own. They're both being raised, the quotient's being raised to the power, so you can give them each their own. So now we're going to use the rule that we just came up with to simplify the following expressions. So in this case, I'm going to do 3 to the 7th over 2 to the 7th. Since I know those numbers are going to be pretty big, I'm just going to leave it like that for now. But from here on out, you're actually going to simplify like you would actually do out the math. So pause the video, try these 6, press play when you're ready to check your answers. So here, we're just giving each of these the power, pretty straightforward. Here you're raising everything inside to the 2nd power, so negative 7 to the 2nd power means to do negative 7 times itself, which is where positive 49 comes from. Same idea here, you're doing negative 2 times negative 2 times negative 2 times negative 2, which would be positive 16, and then over y to the 4th. Here you have 4 separate items. You have a 4, an x squared, a 5, and a y that are all being raised to the 3rd power. So 4 to the 3rd is 64, x to the 2nd to the 3rd, remember you can multiply their exponents. 5 to the 3rd, sorry, that should have been 125. and then y to the third is that. And then a to the second to the fifth would be a to the 10th over b to the fifth. So these four just have a lot more going on, which is why they're considered more difficult. What you want to do in each case is get rid of the parentheses first, and then even though, like with fractions, you can cancel vertically or diagonally, I think it's a little bit easier if after getting rid of the parentheses, you multiply straight across and then simplify when you're done. So we'll do the first one together, and then you'll try the next three on your own. So for the first one, the way that I'm going to get rid of parentheses is by raising everything inside to the fourth power. And I have a 2, an f squared, a g cubed, a 3, an f, and a g. So I have 6 items that need to get raised to the fourth power. So 2 to the fourth power would be 16. F squared to the fourth would be f to the 8th. G to the third to the fourth would be g to the 12th. That's because power to a power, you get to multiply the exponents. 3 to the fourth would be 81. And then I have f to the fourth, g to the fourth. And now I can look to cross cancel. So 16 over 81 can't cancel at all. F to the 8th over f to the 4th. If I apply my subtraction rule, I get f to the 4th. Also, if you think about it, you'd have 8 f's on top, 4 f's on bottom. 4 of the 8 would cancel, leaving 4 remaining on top. And then g to the 8th, because g to the 12th over g to the 4th, leave you with g to the 8th. So try these three, pause the video, press play when you're ready to check your answer. So on this first example, the first thing you would do is cube everything inside of this set of parentheses, which gives you 3 to the third is 27, and then s to the third, t to the third. My other three parts just came down. I rewrote these three right here. So then I just multiplied straight across. I could vertically cancel or cross cancel, but I don't want to mark up my fractions with all the canceling lines. So 2 times 27 is 54. S cubed times s cubed is s to the 6th. T cubed times t cubed is t to the 6th. S times s squared is s cubed. T squared times t is t cubed. And then s to the 6th over s to the 3rd becomes s to the 3rd, because 3 of your s's would cancel, leaving 3 s's on top. And then t to the 6th over t to the 3rd is t to the 3rd. So that's your final answer for that one. On the next example, the first thing that you need to do is raise everything in this first set of parentheses to the second power. So 2 to the second is 4, m to the 5th to the second is m to the 10th, n to the second is just n to the second, 4 to the second is 16, m to the second is m to the 4th. And I also raised everything here to the second power, so m to the second, n to the 4th to the second, n to the 8th, 5 squared is 25, and then n to the second. Then I multiplied straight across. So 4 times 1 would just be 4, m to the 10th times m to the second is m to the 12th, n squared times n to the 8th is n to the 10th, 16 times 25 is 400, m to the 4th, n squared just comes over. 4 and 400 could cancel to become 1 over 100, and then m to the 12th over m to the 4th leaves 8 m's remaining on top, n to the 10th over n squared leaves 8 n's remaining on top. And then this last example, so I started by cubing everything in the first set, which got me 3 cubed is 27, x cubed cubed is x to the 9th, y cubed, x squared cubed is x to the 6th, and then I squared everything here. So y squared squared is y to the 4th, x to the 4th squared is x to the 8th, 5 squared is 25, y squared is y squared. Multiply straight across, you get 27, x to the 17th, y to the 7th, 25, x to the 6th, y squared. 27 over 25 can't be reduced. X to the 17th over x to the 6th would leave 11 remaining x's on top. Y to the 7th over y squared would leave 5 y's left over on top.